So last time we focused on 3 parentheses stoichiometry problems where we started at grams, converted to moles of what we knew, converted to moles of unknown, and ended at grams of unknown. And these next set of stoichiometry problems will be ones that have an added element to them where we will be asked to either find or we will start with the volume of a liquid or solid. So this is not liters of a gas at STP. Liters of a gas at STP will do next. Those are going to be ones where we use 22.414. But these, since they are liquid or solid, we need to use the density of that liquid or solid. That's going to need an additional parenthesis. So if I start with the volume of a liquid or solid, I'm going to need one more parenthesis to convert to grams. Or if the question asks me for the volume of a liquid or solid, I'm going to need one more parenthesis to convert from grams to the liquid. So these will generally take 4 parentheses. Now remember, density is always going to be listed as a mass per volume. So either a grams per milliliter, sometimes grams per liter. And anytime that we have a fractional unit for our density, what we can do is break that up into a conversion factor by just literally taking the divided by and splitting the density up there. The number goes along with the grams. So it's going to be that many grams, whatever the particular compound or element's mass is, equal to 1 milliliter. So for example, water, and we're going to use this one a lot. So this conversion factor is one that you're going to use a lot on your homework and a lot on our sample problems. The density of water is 0.99705 grams per milliliter. Whenever it's per milliliter, we always think of it as being per 1 milliliter. So what that means is 0.99705 grams is equal to, it's another conversion factor, 1 milliliter. And what that means is you can put either one of those in your parentheses. So for example, here's another density, the density of gold, 19.3 grams per centimeter cubed. So that means 19.3 grams would be equal to 1 centimeter cubed. That mass of gold will have a volume of gold of 1 centimeter cubed. If I want to go from volume to mass, remember we always say 2 goes on top. So to go from volume to mass, I would want the mass part of the density on top, 19.3 grams on the top and 1 milliliter on the bottom. But if I want to go from mass to volume, I would want the volume part on top. So 1 milliliter, you guys remember that a milliliter is exactly equal to a centimeter cubed. So I'm sort of using those ones interchangeably. 1 milliliter or 1 centimeter cubed is equal to 19.3 grams. So where students get a little tripped up on this sometimes is that they forget that the mass always goes, or the number always goes with the mass unit. So notice that for gold, 19.3 will always go with grams, and the 1 is always part of the denominator. It's always part of either 1 milliliter or 1 liter or 1 centimeter cubed. At any time, you can always go back and use the formula that we have used for density before. Density equals mass over volume. So if the question gives you volume, you can use density equals mass over volume to solve for mass and then do a stoichiometry problem with mass. Or if the question asks for volume, you could get mass and then at the end convert to volume via density. But the 4 parentheses will actually save you a lot of time. So we're going to do a few sample problems with these. The first one, number 7 here, how many milliliters of water are produced when 74.90 grams of magnesium hydroxide are reacted? And of course, in a stoichiometry problem, we need to use a balanced chemical equation. So the question says milliliters of water. So since that's volume of water, I know that I'm going to need to be using the density of water. Remember on the previous page, 0.99, let me erase that, 0.99705 grams per milliliter is the density of water at 25 degrees Celsius. So I'm going to be using that number, but I'm going to use that number at the end because this question, right, I circled the do, volume of water is what I want to solve for, so that's going to be at the end. I'm going to start with 74.90 grams of magnesium hydroxide. So of course I take the number that I start with and put that out front. And the first thing that I always do is convert to moles. So if you think back to the mole map that we were using, right? Where am I starting in this problem? Well, I'm starting at grams. And so the first thing I need to do is convert to moles of magnesium hydroxide. Then I'm going to convert to moles of water. Then I'm going to convert to grams of water. Then I'm going to convert to volume of water using the density. Okay, so think about every time I make a jump, that's going to be a separate parenthesis. So if I go back to this question, the first thing I want to do is convert from grams of magnesium hydroxide to moles of magnesium hydroxide. So 1 mole of magnesium hydroxide, and I find that number on the periodic table. It's 58.326 grams of magnesium hydroxide. Right? The question's asking about water, so I use the coefficients from the balanced chemical equation here. Right? The only time I use the coefficients is when I have a mole over mole parenthesis. So I would have 3 moles of magnesium hydroxide will produce 6 moles of water. Right? Whenever I'm at moles of unknown, remember the next thing I go to is grams. A lot of students want to use the density right here, but then your units wouldn't cancel out. We're using dimensional analysis. We're trying to make sure that our units cancel out. So this must be 1 mole of water, and that's equal to 18.016 grams of water. And now finally, I can use the density of water. The number part, 0.99705, always goes with the mass, and 1 milliliter is going to go on top. Remember, whatever I'm converting to is going to go on the top. I want to convert to milliliters, so milliliters went on the top. And look at how my dimensional analysis cancels out. Grams of magnesium hydroxide cancels out with grams of magnesium hydroxide. Moles of magnesium hydroxide, moles of magnesium hydroxide. Moles of water, grams of water, grams of water. So this is what I plug into my calculator. In terms of significant figures, any number off the periodic table is going to have 4 significant figures, and my density has 5 significant figures. So my answer is going to have 4 significant figures, and that's 46.41 milliliters of water. So what is that saying? That's saying that if I react 74.90 grams of magnesium hydroxide, if I start with that much magnesium hydroxide, this is what volume of water will be made in the process of this chemical reaction. Okay, let's do another one. This one's going to be slightly different because it's not asking us to find milliliters of water. It's asking us to find grams of magnesium phosphate, and this time we're starting with volume of water. So again, 105.2 milliliters of water. My clue goes out front. My first parenthesis, since this is milliliters of water, this must be milliliters of water here. Remember from the density of water that it's 1 milliliter of water 0.99705 grams of water, right? I'm using the density of water. If I go back up to my mole map, right, I'm starting with volume of water and I'm ending with grams. So my mole map looks a little different this time. I'm starting here at volume of water. So I'm going to make one parenthesis to convert to grams of water, one parenthesis to convert to moles of water, one parenthesis to convert to grams of, I believe it was magnesium phosphate, and another parenthesis to convert to grams of magnesium phosphate. So 4 parentheses total. So the first thing I'm starting with, I already converted from milliliters of water to grams of water. Now it just becomes just like the problems we did a few days ago, right? 18.016 grams of water, 1 mole of water, because we always want to convert to moles. And then using the coefficients from the balanced chemical equation, right? 6 moles of water, so 6 moles of water, and now I want to convert to, here it is, magnesium phosphate. So 1 mole of magnesium phosphate. And what does the question ask me to find? The question asks me to find grams of magnesium phosphate. So 1 mole of magnesium phosphate, and the molar mass for that, 262.87 grams. Okay, so I plug all this into my calculator, right? Going through each parenthesis, multiplying by the top, dividing by the bottom. Let's look at how our dimensional analysis cancels out. Milliliters of water cancels. Grams of water, moles of water, moles of water, moles of magnesium phosphate, moles of magnesium phosphate. So all I'm left with is grams. And my answer comes out to be 255.1 grams of magnesium phosphate. Okay. And the next one, we're not using the density of water in 8B. What we're using is the density of phosphoric acid. Phosphoric acid is H3PO4. Phosphoric acid has a density of 1.88 grams per centimeter cubed. That means 1.88 grams is equal to 1 centimeter cubed. The question asks for what volume of phosphoric acid is needed to neutralize 100 grams of magnesium hydroxide. See if you can do this problem on your own. So pause right here. Try this problem on your own and then see how, check your work, unpause, and see how you did. So we're going to start with 100.0 grams of magnesium hydroxide. Magnesium hydroxide is a base. Bases usually end in OH, hydroxide. So the first thing I always do is convert to moles. 1 mole of magnesium hydroxide has a mass of 58.326 grams. Right? The next step is always converting from moles of one compound to moles of the other compound. That's when I use the coefficients from the balanced chemical equation. 3 moles of magnesium hydroxide, that's the coefficient in the balanced chemical equation, will require 2 moles of phosphoric acid, H3PO4. And now, since I want to go to volume of phosphoric acid, I need to go to grams first. What a lot of students do here, I'm going to do this incorrectly, is they'll write 1 mole of H3PO4 because they know that the units have to match up, but then they'll do something like is equal to 1.88 grams per centimeter cubed. But if you think of this, is not a conversion factor, right? A mole of phosphoric acid doesn't have a density of 1.88 grams per centimeter cubed. Any amount of phosphoric acid has that density. So this is not how you solve this problem. What we need to do here is 2 parentheses. So the first thing I'm going to do is convert to grams. So 1 mole of H3PO4, and then the molar mass, 97.994 grams. Now I use the density, right? I use the density of phosphoric acid, 1.88 grams is equal to 1 centimeter cubed, or 1 milliliter, right? Because that will make it so that the units will cancel out, right? Grams of magnesium hydroxide, grams of magnesium hydroxide. Moles of magnesium hydroxide, moles of magnesium hydroxide. Moles of phosphoric acid, grams of phosphoric acid, and grams of phosphoric acid. Okay, significant figures, that number has 4. All the numbers off the periodic table have 4. Density does count. How do we know the density of phosphoric acid? We measured it at some point. So the fact that that only has 3 significant figures does mean that my answer is only going to have 3 significant figures. So 59.58 rounds up to 59.6, and that would be centimeters cubed or milliliters of phosphoric acid. So hopefully you got that. If you didn't get that, or you didn't get any of these answers, go back and rewind the video and watch your homework. So we're going to try some of these problems using density. So the homework that you're going to do is that we just did. Numbers 15, number 16, I can tell, see milliliters of water. This one, volume of water. Those ones are the ones that you can try. That will match up with those 7 and 8A and 8B that we just did. If you want to look at 14, 13, 12, 11, those are going to be what actually tomorrow's lesson is going to be all about, or I should say the next lesson is going to be all about. It's actually not that hard. It's using all that stuff from chapter 12 that we learned, like 1 mole is equal to 22.414 liters of a gas at STP, and using 1 mole is equal to 6.022 times 10 to the 23rd atoms, molecules, or formula units. So if you wanted to see and kill 2 birds with 1 stone, you could try 11, 12, 13, 14, but only numbers 15 and 16 will kind of directly match up with the practice problems that we tried. Okay, so give these a try, check your answers with the answer key that's posted, ask questions in our Q&A, and then next time we'll go over putting everything together and then actually adding in heat.